So in this video, we're going to draw the Lewis structures for 3 different molecules. So you can use this to double check your work. We're doing SiH4, SF2, and Br2. So again, we're going to use the same procedures that we used before to draw these Lewis structures. First step is to count the number of valence electrons. So silicon is in group 14. It's going to give us 4 valence electrons. Hydrogen is in group 1. It's going to give us 4 because there's 4 hydrogen atoms in this molecule. So we're going to take that 1 valence electrons times it by 4, which means there's a total of 8 valence electrons that we're going to draw in this Lewis structure. Silicon is our central atom. There's only 1, and it has 4 unshared dots, so it's going to go in the middle. We're going to connect it to 4 hydrogen atoms, and then we're going to count the number of valence electrons. 2, 4, 6, 8. That's the number that I wanted. So this is the correct Lewis structure for this molecule. Let's look at the next example. Sulfur is in group 16. It's going to give us 6 valence electrons. Fluorine is in group 17. It's going to give us 7 valence electrons, but there's 2 of them. So 6 plus 7 times 2 would be 14. 6 plus 14 gives us a total of 20 valence electrons in this Lewis structure. Sulfur is our central atom because it has more unshared electrons. So we're going to put sulfur in the middle. We're going to connect it to 2 fluorines. So let's count the number of electrons. Each line is 2 dots, so 2, 4. Well, that's not quite enough because we need to get to 20 electrons. So we're going to have to add in all of our extra unshared pairs around each atom, the fluorine and the sulfur. So we're going to add 2 pairs of electrons to the sulfur to give an octet. 2, 4, 6, 8. There's 8 electrons around the sulfur atom. Then we're going to add 3 pairs of electrons around the fluorine atoms to give fluorine an octet. 2, 4, 6, 8. 2, 4, 6, 8. Now let's count overall how many electrons are in this diagram. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That is the number of valence electrons I needed, so this is the correct Lewis structure. For our last example, bromine, there's 2 of them. Bromine is in group 17, so 7 times 2, it's going to be a total of 14 valence electrons. There's not really a central atom here because the only way to connect 2 atoms is with a single bonding pair, a single line. So there's not really a central atom, we're just connecting these 2 atoms with a single line. But that's only 2 electrons, we're trying to get 14. So we have to add in 3 pairs to each bromine atom, 2, 4, 6, to give us an octet here, 2, 4, 6, 8 on this bromine atom, and then 3 pairs on the other side, 2, 4, 6, 8. That's an octet. Now let's count the whole diagram. 2, 4, 6, 8, 10, 12, 14 valence electrons. That's the correct number, so this is the correct Lewis structure.